Here we're starting vectors. We'll be focusing mainly on the area, but before that, let's look at a quick recap. So a vector is represented by a column matrix or a column vector. For example, 3, 4. Let's name this vector as AB. This means it starts at A and ends at B. So if we had to graphically represent this vector, and this is the point A, then this value, the upper value, represents the x-axis and this represents the y-axis. So we would move 3 spaces towards the right for the on the x-axis and then 4 spaces upwards on the y-axis. So 1, 2, 3, 1, 2, 3, 4. This would be B, and this is the vector AB. To find the magnitude of a vector, we use the Pythagoras theorem. In the modified version, the magnitude is represented as the name of the vector with a modulus sign. So AB, magnitude of AB is equals to under root 3 square plus 4 square. That is equals to 5. Parallel vectors are those vectors which have the same direction. Therefore, they have the same gradient. In a vector, gradient can be found by dividing the lower value by the upper value, as this is the difference on the y-axis and this is the difference on the x-axis. So the gradient of this vector would be 2. Now if there was another vector 1, 2, the gradient again would be 2. So these two vectors are parallel. Equal vectors are those that have both magnitude and direction equal. Scalar multiple is a scalar number, that means it does not have direction, which is multiplied to a vector to change its magnitude or direction. If we have a vector 2, 3 and we have to find the vector which is opposite in direction but equal, we would multiply this by -1. So the vector opposite to 2, 3 would be -2, -3. Similarly, if we wanted a vector which was twice the size of 2, 3, we would multiply it by 2, 2 being the scalar multiple, and the new vector would be 4, 6. These two will be parallel, but this will be twice this one. Addition of vectors is by 2 methods: the head-to-tail rule and the parallelogram rule. For the head-to-tail rule, we form a triangle. For example, if this is the triangle, this vector is A and this vector is B. So the resultant vector, which will be this vector, will be A plus B. Another vector is the position vector. A position vector is a vector that has its tail at origin. Tail at origin. So, for example, if this is the origin this is A and this is B. The position vector of A will be OA, that is this vector. The position vector of B would be OB, this vector. Now if we have to find AB, and we have their position vectors, so the formula is the position vector of the second variable, the second point, the position vector of the second point minus the position vector of the first point. That is written as OB minus OA. Now why is this so? If we had to find AB, then the direction of OA should have been from A to O. But we have the position vector from O to A. Therefore, we put a minus sign in front of that to make the direction opposite to it, which becomes AO, and OB is added to it. So it's OB minus OA. A few more tips about vectors. If two vectors are parallel, they can be written as xy and kxy. Here k represents the scalar multiple, which can be taken common from these two numbers if they are parallel. Also, if we have a point C 3, 4, its position vector will always be 3, 4. Or if we have a point E -2, 1, its position vector will be -2, 1. Now we're practicing some questions from P1. This question says AB is equals to P and CA is equals to Q and DC is equals to 3 times AB. This is DC and AB is P. So it's 3 times AB means it's 3 times P. Now we have to find DA. DA is equals to DC plus CA. That is 3P plus Q. Next part says E is the point such that BE is equals to KQ. They're saying that there's a point E and BE is equals to KQ. Here K is a scalar multiple. Therefore BE and AC will be parallel, which is why the answer to the next part, which is write down the name given to the special quadrilateral ACBE. As AC and BE are parallel, it is a trapezium. Express AE in terms of P, Q and K. Now let's suppose E is somewhere here. So we have to find AE in terms of P, K and Q. AE will be P plus KQ, as since AE is equals to AB, which is P, plus BE, which is KQ. So it's P plus KQ. The next part is, given that D, A and E lie on a straight line, find the value of K. So they're saying D, A and E lie on a straight line. This means now E should be somewhere here, so that this is a straight line. This point is E. BE, as we found, was KQ and AE was P plus KQ. Now since this is a straight line, so DA and AE have the same gradient. Therefore they are scalar multiples of each other. So we can write that DA is equals to H as a scalar. DA is equals to H as a scalar multiplied by AE, since they have the same gradient. So DA, as we found earlier, was 3P plus Q. So 3P plus Q is equals to H times AE, which was P plus KQ, So 3p plus q equals to hp plus hkq. Comparing coefficients of p first, so h is equals to 3, and then coefficients of q, 1 is equals to hk. Since h is 3, so 1 is equals to 3k, and k is equals to 1 upon 3. The next question isn't exactly about vectors, but it involves transformations along with vectors. Here we have the grid, and the point A is marked, which is 5, 5. They're saying that AB, let's first draw B. So AB is the vector 4 minus 3. This means that we have to move 4 spaces towards the right and 3 spaces downwards, just an approximate. So B is somewhere over here. Now they're saying is AB is mapped onto CD by a reflection in the y-axis. Find CD. When A is reflected along the y-axis, it will come somewhere here, and B, this becomes C, and B will come somewhere here. This will become D. Now what we have to find is this vector. This vector would be the addition of this and this. This distance will still be 4 as it was over here, but the direction changes, so it becomes minus 4. So CD is minus 4, and then here we're going downwards, here also we're going downwards, so it remains minus 3. It's minus 4 minus 3 CD. Next part says AB is mapped onto AE by a rotation center A. A is the center, and a 90-degree clockwise rotation maps AB onto AE. So clockwise means in this direction. This patch will come over here, and it'll go like this. So this will become E. Now this distance was 4. Now this distance is 4. And as this distance was 3, now this distance is 3. To go from A to E, we are moving 3 blocks towards the right on the x-axis. So we'll write minus 3. And we're moving 4 blocks downwards on the y-axis. So it's minus 4. It's minus 3 minus 4. Now they're saying find the length of AB. AB is the vector 4 minus 3. The formula for distance is under root 4 square plus minus 3 square. This is equals to 5. Now we're doing area in vectors. So there are 3 types of questions about area in vectors. The first is about similarity. If there are 2 triangles, like a bigger triangle with a smaller one, and these 2 lines are parallel, so this triangle and this whole bigger triangle are similar. If these 2 lines are in the ratio 1:2, the area of this triangle and this triangle will be in the ratio of 1:4, as it's the square of 1:2. The next method is the ratio between the heights. If the bases of 2 triangles are equal, then the ratio of their areas will be equal to the ratio of their heights. For example, these two triangles, one is in green, the other is in blue. So for this triangle and this triangle, this is the base which is equal for both. As the ratio of their areas would be half into base into height b1 h1 upon half into b2 into h2. Now half and half get cancelled. As both bases are equal, so b and b get cancelled. So a1 upon a2 is equals to h1 upon h2, the height of this and the height of this. The last method is the ratio between the bases. This is applicable when the heights of the two triangles are equal. For example, in these two triangles, the height is the same, which is this length. The base of the bigger triangle is this, while the base of the smaller triangle, the base of the bigger triangle is this, while the base of the smaller triangle is this. Therefore, as area is equals to half into b1 into h1 upon half into b2 into h2, half and half get cancelled. Heights are equal, so h and h get cancelled. So a1 upon a2 equals to b1 upon b2. That is this length upon this length. Now questions for area. In the diagram, triangles OAB and OCD are similar. OAB and OCD are similar. So we are applying similarity over here. OA is equals to A, OB is equals to B, and BC is equals to 4A minus B. Now we have to find AB. AB is equals to... Now, because we have the position vectors, we can use the formula of position vectors. That is the position vector of the second point, that is B. So OB minus OA. OB is B and OA is A, so B minus A. AC. Now for AC, we need AB plus BC. AB is B minus A and BC is 4A minus B. So the answer is 3A, just 3A. Now CD is the next part. CD is this line. Now for CD, since AC is 3 times OA, this means that these two triangles are in the ratio of 1 is to 4, because OC is 4 and OA is 1A and 4. So now CD will be 4 times of AB. CD is equals to 4 times AB is equals to 4 times B minus A is equals to 4B minus 4A. Now for the ratio parts, the first part is perimeter of triangle OAB, that is this triangle is to perimeter of triangle OCD. For perimeters, the ratio will remain as the ratio of the sides, that is 1 is to 4. Next part is area of triangle OAB is to area of triangle ABDC. This is OAB and ABDC. Ratio of area of this triangle and area of this triangle would have been 1 upon 4 whole square, that is 1 upon 16. But as we need ratio of this triangle to ratio of the bigger triangle minus this triangle, because we need this trapezium, so we'll subtract 1 from the ratio of the larger triangle to get the ratio of the areas of this triangle and this trapezium. So it is 1:15. The next question is question 15. In the diagram, T is the point of intersection of the diagonals of the quadrilateral PQRS. PQRS is a quadrilateral and T is the midpoint of the diagonals. It's the intersection point of the diagonals. PR is equals to 3 times PT. So PR is equals to 3 times PT. And PS is equals to 5 times B. PS is 5B. PQ is 4A plus B. And PR is 3A plus 12B. Express as simply as possible in terms of A and B, RS. This is RS. For RS, we have RS is equals to RP plus PS. PR is 3A plus 12B. So RP is minus 3A minus 12B plus PS, which is 5B. So RS is equals to minus 3A minus 7B. Next part is RT. In the beginning, we read over here that PR is equals to 3 times of PT. PR is 3 times of PT. Means that there are 3 units. This is 1, this is 2, and this is 3. These 3 are equal. So TR is equals to 2 upon 3 of PR, that is 3A plus 12B. So TR is equals to 2A plus 8B. Now we needed RT, so RT will be equals to minus 2A minus 8B. Now the next part is find RQ. RQ is this line. So RQ is equals to RT plus is RP plus PQ. Now we were given PR as 3A plus 12B. So RP will be minus 3A minus 12B plus PQ. PQ is 4A plus B, plus 4A plus B is equals to A minus 11B. That is RQ. Therefore RQ is equals to A minus 11B. Now the next part says show that QT is 3 times B minus A. QT is 3 times B minus A. The vector QT is equals to QR plus RT. QR RQ is A minus 11B. So QR will be 11B minus A. And RT we found was minus 2A minus 8B. So minus 2A minus 8B. So QT will be 3B minus 3A equals to 3B minus A. This is what we had to prove. Now the next part says express QS as simply as possible in terms of A and B. Now QS is equals to QR plus RS. RQ is A minus 11B, so QR is 11B minus A. And RS is minus 3A minus 7B. So QS is equals to 4B minus 4A. QS is equals to 4B minus 4A. Now the next part says calculate QT upon QS. QT upon QS. QT, we found that QT was 3B minus A and QS is 4B minus 4A. So taking 4 common, it's 4B minus A. B minus A gets cancelled, 3 upon 4. This is QT upon QS. The next part is area of PQT upon area of PQS. So area of PQT, that is this, the shaded region, is to area of PQS, this whole region. So here we can see that the height, or I'll draw this on the whiteboard. We have to find the ratio of area of triangle PQT upon area of triangle PQS. So the area of triangle PQT, the shaded region, is to the area of this whole triangle. Now here we can see that the height, which is the blue one, is equal for both triangles. So the ratio of their areas will be equal to the ratio of their bases. Now the ratio of their bases is QT upon TS. QT upon QS we found in the last part was 3 upon 4. So the answer to this part will also be 3 upon 4. Now the next part says area of PQT is to area of RQT. I'll draw this diagram first. This is Q, this is P, S, this point is T, and this is R. We need the ratio of the area of triangle PQT upon area of triangle RQT. So shading those triangles, PQT is this triangle and RQT is this triangle shaded in blue. Here once again we can see that the height is equal for both triangles. So again we'll use the ratio of the bases. The ratio of the bases will be PT upon RT. The question said that PR, which is this, is equals to 3 times PT. So it means that there are 3 units, this, and this is equal. This means that this is 1 and this is 2. So the answer will be 1 upon 2.